Good evening, everyone.
Good evening, ma'am.
Good
Good evening, ma'am.
evening.
Good evening, ma'am.
How are you all? All good?
Yes, ma'am.
How was the exam?
It was good, ma'am.
It was good. Was it easy?
Yes, ma'am.
Yeah.
Yes, ma'am. Yes.
That's nice.
Moderate.
Yes,
Mm-hmm. Nice. It was moderate. It was easy. It was not hard, right?
Yes,
yes,
ma'am.
ma'am.
Nice. Okay, then. So,
Ma'am, are the scores released?
scores have not been released. It will be released in 2 to 3 days, I guess. This week it will be released, I guess. Yeah.
Because in some of our groups, we are getting the score checker links and that they are
Yeah,
giving.
that will be like not the final scores. It will be the scores like according to what you have, like the computer generated one.
Okay, so the
So,
score checker is not the actual one, right?
uh,
Okay, okay.
okay then. So, okay. So today we have week 9 open session. So have you guys gone through the videos of week 9?
Ma'am, two lectures are left.
2 lectures are left. Okay, what about others?
Watchman.
Watched?
Yeah.
Good. Okay then. So what is there in week 9? Anyone?
Random variable.
Yeah, it's about random variable. What are the topics in that?
Expected value and
Discrete random
uh,
variable.
mass function. I think PMF है and और क्या है?
Okay. So we have one topic is random
Variance
variable.
and
Okay. Let me just.
deviation.
Kind of random variable and
Hmm. We have first random variable, then we have two divisions of random variable, which is a discrete one and then the continuous one. Then we have what we call the probability mass function. And then the third is CDF, which is cumulative distribution function. These are the three topics that are there in this week 9. Fine. Okay. Now the first comes is random variable. Anybody knows what is a random variable?
Choosing any value from sample space.
Ma'am, quantifying any kind of event happening and without bothering about the outcomes, the actual outcomes of the experiment.
Yeah, we can say that. Or we can say that it's a real valued function on a sample space. That is my random variable. Okay, so let's suppose I'm tossing a coin. Okay, no, let's take. I'm throwing a dice twice. Okay, so if I'm throwing a dice twice, what will be my sample space? It will be 1, 1, 2 till 1, 6. Similarly, 2, 1, 2, 2, like that, right? So I will be having how many sample?
36.
I will be having 36, right? So in total, I am having 36. Now, what is a random variable? Let's suppose I am just interested that my after throwing a dice, my sum of the outcome should be equal to 7. Okay, so if my sum of the outcome are 7, what are my possibilities?
1, comma
5,
6, 2, comma 5, 6, comma 1.
then
3,
Like
4,3.
two
that's
comma
it.
five.
Yeah. So in here, we are just trying to find out the sum of the outcome is 7. We are not interested at what, like after throwing what, we are getting sum as 7. We are just interested that I should get the sum of 7. So this is my x. So I'm representing one thing, one numerical quantity with some variable which is known as a random variable. Okay. Similarly, I can say that y is my random variable, which is like the outcome is that my one of the die is 4. That means like one of the die, that means the first die that I have thrown is showing 4. Okay, so that will be what? 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, and 4 comma 6, like that. So this is my y variable. So this is my random variable y, which is actually just telling me the outcomes that my first die should be 4. X is also a random variable, which is showing that the sum of the outcome is 7. So actually what we are doing, we are just representing, okay, a real valued function for some numerical quantity defined on a sample space. Fine. That is my random variable. Is this fine?
Yes, ma'am.
Okay. Now let's in this, with this random variable also, probabilities are also defined. Yes or no?
Yes, ma'am.
Yes, ma'am.
Right? So let's suppose, let's take an example. Which is the activity? Okay, let's take one example. Okay. I am throwing a coin 2 times. Okay. So what is my sample space? It is HH, HT, TH, and TT. These are my sample space. Okay. Now my random variable X is basically that that I get heads. Okay. So for my X, what are my possible values? What is the what is the probability associated with it?
3 by 4.
It will be
3
3
by
by
4.
4. Exactly. So with each of the random variable, I will be having one probability associated with it. Okay. That is my random variable and the probabilities associated. Fine. Similarly,
Yeah.
let's suppose if I'm
Hello, ma'am, how it is 3 by 4?
we are just stating that X is just getting ahead. So we can get head, like this is one outcome, this is one outcome, and this is one outcome. So from the 4, I am having 3 outcomes in which I am getting head. Correct?
Yes, ma'am.
Yeah.
Yes, ma'am.
That's it. So we are just telling that with the random variable, a probability is always defined with it. Okay. Now this random variable is actually of 2 types. One is discrete and one is continuous.
Continuous.
Yeah. What do you mean by discrete?
Where we have this numbers, right? Integer numbers used for counting something, and we call it as a discrete.
Yeah, basically a discrete random variable is a random variable which is a countable random variable. Okay, so let's suppose I'm having in the sense that if I'm drawing a number line, I can distinctly write the numbers 1, 2, 3, or like 0, 1, 2, or 5, 9, 6. So in a number line, I can just represent it distinctly. That is my discrete random variable. Okay, so the main point is it should be countable. That is the main thing for a discrete. If you can count it, that is a discrete random variable. Okay. Now,
Yeah.
for continuous, we can't count it. Okay, that is the main difference. In discrete, we can count it. In continuous, we can't count it. Okay, so it is like, what can we say? Like if I form a number line, I can't represent it distinctly. I will be representing it that my values are between 0 and 1. That is my continuous. So this is representing as a continuous random variable in which I am just showing the interval on a number line. Okay, so in a on a number line, if I can show it distinctly like this, it is a discrete random variable. But if on a number line, if I'm showing as an interval form, then I say it's a continuous random variable. Okay.
Yes, ma'am.
Okay, and the main thing is, if mostly my measurable quantities are my continuous random variable. Okay, let's take the example like for a discrete random variable, what are my examples? The number of books, right? Then number of tables. Then any other?
Number of pens, pencils, etc.
Number of pens. Okay. Languages. Then books, tables, pens, languages. So those are the things that so number of books we can count, tables we can count, pens we can count, languages we can count. So all of the things that we can count is a discrete random variable. Now, can you guys tell me the example of a continuous random variable?
Height of a person.
Just remember that in
Height,
continuous,
weight.
it is a measurable quantity. Okay, it should be a measurable. So height, it is a measurable quantity.
Weight.
Second, weight. Then
Time, temperature.
Temperature.
time, temperature, area. So those things that are like measurable and we can't count it, that is my continuous random variable. Is the difference clear between discrete and a continuous random variable?
Yes, ma'am.
Yes, ma'am.
Sure.
Ma'am, there is always a unit behind a continuous random variable.
Yes. See, my height will be in what? Like inches or like centimeters or
Yes.
right? We can have for weight, we can have kilogram, we can have gram. For time, it can be PM, AM, temperature, degree Celsius or degree Fahrenheit, like that. Areas like square feet, like that. So we have measures, we have unit associated with it. Okay. So the main thing you just have to remember, if I can count that thing, that is my discrete. If I can't count, like it's a measurable thing, that's a continuous random. That's the difference between discrete and continuous. Is this fine?
Then even if we say for a time it is 7 p.m. or 8 p.m. something like that, it is still a continuous quantity, right? And not a discrete one.
So time is, see, it depends upon time. Okay, it depends upon the situation. So if you see here, you're just telling us some distinct value like time.
Like, ma'am, time interval, like between 2 to 3, how many people enter the house?
Then it's a continuous.
But if I have to specify a unique time, like a point of time, so will that be a discrete or is it also a continuous?
Sorry, once again.
Like if I have to specify a point of time, like 7 p.m., so is that still a
If
continuous
you
or
have
it is
specified, if you have specified directly that like 2:37 a.m., 2 p.m. or something like that is like, so that is what, like it depends upon the situation. If you're just taking the time like doing a work or completing a work or something, that will be an interval. Like you can complete it in 2 hours, you can complete it in 3 hours. So that means if I have to show it, I will be showing that the completion of work is between 1 to 4 hours or something like that. So I can complete it in 1 hour, I can complete it in 1.5 hours, I can complete in 1 hour 10 minutes also, I can complete in 1 hour 5 minutes also. So I don't have that particular thing, right? Distinct, I don't have distinct time. So it depends upon situation to situation. What they are asking, what they have represented time as. You have
So
to
if I
take that.
say this task completes in 5 milliseconds, then it is a discrete, right? Because I'm specifying a point of time. Rather, if I
Hmm.
say like we take 2 hours of time to complete it, so it is a continuous. Is that correct?
You have taken what?
Like if I say a task is getting completed in exactly 5 milliseconds of time, so I think that
That's
is
it.
a discrete one. Okay,
Discrete.
or thank you.
Okay. Okay. Now, so okay, so we were talking about discrete and continuous. So we were talking about discrete only. Okay. So discrete is which are countable. Now the thing is, for a discrete variable, we have probabilities associated with it, which is known as probability mass function, which is known as PMF. Okay, just remember this thing. For a discrete case, we have probability mass function, which is known as PMF. Okay, so let's suppose I have a random variable x. Okay, so if I am having a random variable x and it has n possible values, let's suppose x1, x2, x3, x4, like that, xn values I have for a x random variable. Then with each of these random variable x1, x2, I have a probability associated, which is known as P1, P2, P3, P4, like that, P5. Okay, this is my, so this thing is actually known as the PMF, which is the probability mass function or probability associated with each of these discrete random variable. Is this fine? PMF is fine. What is PMF? Is it clear?
Yes,
Could you
ma'am.
please repeat this again?
PMF.
Repeat, like I have missed the last 10 minutes.
Okay, so I'll just repeat it once again. So we were studying about discrete and continuous. Now we will be studying about the discrete case only. Okay, we are just talking about discrete random variable. Now, a discrete random variable has a probability associated. I was talking about for each of the random variable, there are probabilities associated with it, right? So for a discrete random variable, that probability is known as probability mass function, which is known as the PMF. So if my x is a random variable and for that x, I have n different values, possible values. So for each of these n values, I have probabilities associated with it, which is for x1, it is P1, for x2, it is P2, for x3, it is P3, x4 is P4, and similarly till xn, it is like Pn. So these probabilities actually is known as the probability mass function. So you have to remember that for discrete random variable, PMF is used. Okay. Yes or no?
Got it.
Yes, ma'am.
Yes, ma'am.
Got it? Yeah.
Yes.
Okay. So now this PMF is actually having two properties that you have to remember. Okay. There are two properties which are important. Okay. So the first property is that my PX, all the probabilities associated with it should be greater than equal to 0 for each of these xi. And the second thing is, if I sum all the probabilities of xi, okay, it should be equal to 1. That means my all this sum of that is P1 plus P2 plus Pn, it should be equal to 1. If all both of these condition is satisfied, then I say that it is a correct PMF. Okay, is this thing clear?
Yes, ma'am.
Okay, let's take an
Yeah,
example.
yeah.
Let's take an example. Let's suppose x is a random variable which is taking values 0, 1, and 2. And we have a probability associated with it, which is like 1 by 4, 1 by 2, and 1 by 4. Can you tell me whether this is a correct PMF or not?
Yes, it is correct.
Yes, correct.
Yes,
Yeah.
ma'am.
So the first property is the PXI should be greater than equal, all the probability should be greater than equal to 0. They are. And the second property is the sum should be equal to 1. So is the sum equal to 1? They are equal to 1. So this is a correct PMF. Okay. Similarly, let's suppose my X is taking values 1, 2, 3, 4, and 5. And the probabilities associated with are 0.4, 0.1, 0.2, 0.1, and 0.3. Can you tell me whether this is a correct PMF?
No,
No.
no.
No. Okay. So is the first property being fulfilled? Yes. Is
Yes.
the second property being fulfilled?
Yes.
No.
No.
No. That's why this is not a correct PMF. Fine?
Yes.
Yes?
Yes, ma'am.
So this is what a probability mass function is and their properties. So you just have to remember there's two properties if you have to consider, if you have to see whether it is having a correct PMF or not. Okay? This
Yes,
was
ma'am.
all about PMF.
Ma'am, in the lecture, the ma'am has taken some formula of C into lambda I by I factorial. That do we have to remember?
That you don't have to remember.
Okay.
That is just for like I guess she is solving. Let me see. I also don't remember probabilities. She is
But
just calculating the value of C with the help of the property of. Okay, I'll
yeah,
just come back to that. I'll just come back why she has
okay.
told you this thing. I'll come back to that.
But
So it is just that she is just using this property to solve take out like to find the value of some constant C.
so we do not need to remember that formula, no?
No, no, no. You don't have to.
Okay.
Okay. Okay, let's take one activity question. Okay, let's take the first question only. So we have x as a random variable which is taking values 1, 2, 3, 4, and 5. Then we have the probabilities associated with it, which is 0, t, t by 2, 4t square, and 3t by 2. Now you need to find out probability of x equals to 5. You guys solve this and tell me the answer.
Ma'am, it is given 3t by 2.
Yeah. So my probability is x equals to 5 is given to be 3t by 2, correct? But I need the probability. I can't just tell the answer in respect to t, right? I need some value. So what I will do? First, I need to find out this t value. How will I find this t value?
Sum is equal to 1.
Add up
You
and
can
equal
add
to
up
1.
all to equal to 1.
Correct. We know that the sum of all the probabilities is equal to 1. So we will use this property. So that means 0 plus t by 2 plus 4t square plus 3t by 2 is actually 1. Correct? So if you solve this, so this will be 2t plus t plus 8t square
3 by 8, sir.
plus 3 by 2 divided by 2 equals to 1. So 3t 6t plus 8t square equals to 2. So this will be, we can take out common. Here 4t square plus 3t minus 1 equals to 0. Then the t can take values.
4t
He
minus
can 1 by 4. I mean,
1 by 4 and
minus
4.
3.
So t can take two values, minus 1 and 1 by 4. But the thing is, the first property says that all my probability should be greater than 0. So I can't take the value of t as negative. So only 1 by 4 is possible. So that means my probability of x equals to 5 will be what? 3 into 1 by 4 divided by 2. Correct? This will be equal to 3 by 8. Yes or no?
yes.
Is
Yes.
this thing clear?
Yes.
Yes.
Yes, ma'am.
Yeah. So first of all, if we want to calculate this value, the missing value, we will be taking using the second property and then just putting the values. Okay. Okay. Let's see. Okay. Let's take one more example, one more question. My probabilities of x will is given as, okay, 0.4 plus 2k and 0. This k value is when x equals to 0. This is when x equals to 1 and this is otherwise. Now you need to find out the value of k. Can you find out?
Yes, ma'am. 0.
Yes, ma'am.
We'll take the sum and equate it to 1.
Yeah, so basically this thing is same as the previous one. They have just
Yes.
given in this form. So this is x is taking two values, 0 and 1, and the probabilities are like k and 0.4 plus 2k, correct? So now
Yes.
we know from the second property that k plus 0.4 plus 2k is actually 1. So this will be 0.4k, sorry, 0.4 plus 3k equals to 1. And 3k will be 0.6. So k will be 0.2, correct?
Yes, ma'am.
Yes.
So this is how you use the properties of the PMF and solve the questions. Okay. Any other question? Okay, this is so rest of the activity you just do it. Okay. The main thing. Okay. Now, next thing comes up is graph of PMF. Okay. Now, graph of PMF in the sense, let's suppose my X is taking, we are just representing that the probability is in a graphical thing only. So if my X is taking values 0, 1, and 2, then the probabilities associated is 0.25, 0.5, 0.25. So if I have to make a graph, on the x-axis, I have the x variable. Okay, these are my variables like 0, 1, and 2. So these are my variables that my x is taking. Okay, the values. And the y-axis is actually denoting the probabilities. Okay, so this is like 0.2, 0.4, 0.6. So if I make a graph for 0, it is 0.25. So let's suppose this is somewhat here. And for 1, it is like 0.5. So this is somewhat here. Then for 2, it is like 0.25. So this is my graph of a PMF. Okay, just similar to like a bar graph. Okay, so this is how you make for a, and this in this figure we can see that it's like a normal graph, right? Okay, so we can have different type of graph. We can have a uniform graph as well, in which all for all the values my probabilities are same. Okay, so this is like a uniform graph. We can have skewed graph as well, either like this or like this. Okay, or we can have like unsymmetric, in the sense like we don't have any symmetricity in that. Let's suppose like this, like this. So we can have different type of graph for a like if we are drawing for a probability for a random variable. Fine. This is just a case of probability mass function. That's it. Nothing that important. Graph is clear?
Yes.
Yes, ma'am.
Okay. Now the last part comes is CDF. CDF is basically cumulative distribution function. Okay. Do you guys know what do you mean by cumulative distribution function? What do you understand by cumulative distribution function? Anyone?
Ma'am, is it just like that cumulative frequency that we go on adding all and then we get
Correct.
the value?
Okay. So if you see here in the PMF, what we are actually finding out, we are actually finding out probability of X equal to some value, right? At that particular value, what is my probability, correct? That is my probability mass function. But what is cumulative? Cumulative is basically we are trying to find out probability X less than equal to some value A. Let's suppose X less than some value or probability X greater than some value. So that is my cumulative. Okay, so if let's suppose my X is taking value 0, 1 and 2. Okay, so if I need to find out probability of X less than equal to 2, this will be what? Probability of X equals to 0 plus probability of X equals to 1 plus probability of X equals to 2, correct?
Yes,
So
ma'am.
what we are doing, we are actually summing all the probabilities for each of these values, correct? So we are accumulating it. We are adding it, adding all the values. So that's why it is known as a cumulative distribution function. We are actually not finding out that we are not finding out probabilities at that particular point, but we are finding out cumulative probabilities. Okay.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So my CDF, it is actually represented as FA, where it is the probability that X is less than equal to A. Okay, so let's take an example. X is taking values 0 and 1. Okay, and the probabilities associated with it is like, let's take 1 by 2 and 1 by 2 only. Okay, so how do you make the CDF? So it is taking only 0 and 1. Okay, now the probabilities, it's like 0.5, then 1. Okay, now, so we are actually finding out the CDF. So the first thing is, okay, so first thing is till, so the X value is taking only 0 and 1. We need to find out the cumulative thing. So first we will find out for A, if my A is less than 0. If my A is coming less than 0, it will be these values.
0.
It will be 0 only, correct? So that means it is my 0. Now for A, going from 0 to 1. Now at 0, it is having a jump, correct? At 0, it is like 1 by 2. So
Yes.
at 0, this will be 0.5. Now from 0 to 1, it will be 0.5 only. It will go straight, right?
Yes.
Yes,
Ma'am.
right? Now at 1, again it will have a jump, right? What will be the jump?
0.5.
It will be like again 0.5. So in total, I will be having 1.
Yes.
So now from 1, it will go again constant. So this is how I draw a CDF. Got the point? So this is
Yes,
a
ma'am.
CDF. And this thing is, the steps that you see here is actually my PMF. So that's why it is known as, this graph is known as step function.
Ma'am, it's just like a greatest integer function.
Greatest integer function in the sense?
Like we make similar graph in greatest integer function graph, like stepwise.
Okay, sorry, I'm not aware of that topic.
No, ma'am, just I joined a little late. Can you just tell what is the name of this PMF, like the full form?
PMF full form?
Yes, ma'am.
Probability mass function.
Okay, ma'am.
Okay, let's take one more example. You guys understood a little bit about the CDF, how to draw it, how to draw the graph, how to study that graph,
Yes.
right?
Yes.
Let's do one more example. Now my X is taking values 1, 2, 3, and 4. and the probabilities associated with it are 1 by 4, 1 by 2, 1 by 8, and 1 by 8. These are my probabilities. Okay. Now you need to make the CDF. So this is, so the values it is taking is 1, 2, 3, and 4. And these are my probabilities. Let's suppose this is 0.2, 0.4, 0.6, 0.8, and 1. Okay. Now, I'm not writing that CDF thing. I'm just trying to draw it. Okay. So the first thing is I will be taking till 1, it will be 0. Yes.
Yes.
Till 1, it will be 0. Now at 1, it will have a jump, which is 0.25.
25.
Now from this, from 1 to 2, it will be same.
Yes.
Now at 2, it will again be a jump, which is around 0.75.
Yes, jump will be of 0.5 and total will be 0.7.
0.75, right? Now from 2 to 3, it will be same constant. Now at 3, again it will have a jump, which is around 0.9 something. Okay. So like this here. Now from 3 to 4, 0.87 or something. Then from 3 to 4, it will again be a constant. From at 4, it will again have a jump till 1. And from there, it will be a constant. So this thing is a CDF, right? Now this part is basically the step thing is actually my PMF. Okay. So how I concluded it, see, this thing is actually, what is this size? This is actually 1 by 4 only, right? 0.25. Correct. Which is the actual PMF of 1.
Yes, ma'am.
Similarly, this thing, if you just calculate it, this is actually what? 0.5 only. That means this is total 0.75, right? 0.75 minus 0.425, which is actually 0.5, correct? So
Yes, ma'am.
actually what we are doing, we are just subtracting this whole thing minus 1 by 4. Similarly, this thing is also the PMF of 3, which is
0.875.
0.12, right? 125, and this is also like 0.125.
Ma'am, you
So
are
you just
calling the graph PMF and
no, this is CDF.
So, ma'am, in the 0.5 jump, 0.75 is CDF and 0.5 is
The
PMF,
PMF.
right?
Correct. So the thing is, the steps that if you see here, these are my denoting the PMF. The steps. This thing, na, these are my steps.
Okay.
Okay. So these are
And
denoting the
when we
PMF.
will add the previous jumps, then it will become CDF, na?
okay, ma'am. So total is the CDF and individual step is the PMF, right?
Correct. So if you just write this thing, na, in that
Understood.
form, actually, so if my A will be, this can be written as that A less than 1, it is actually 0. Then from when A is going from A 1 to 2, it is actually what? 0.25, which is 1 by 4 only. Then from 2 to 3, it is actually what? 0.75. From 2 to 3, if you see here, 0.75.
Yes, ma'am.
Everybody getting this point?
Yes, ma'am.
Yeah,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah.
Yes.
Then again from 3 to 4, this is like 0.875. Then from when A is greater than equal to 4, it is 1.
1.
Fine.
Yes,
This
ma'am.
thing.
It is the
Yes.
cumulative frequency will written like this. A between 1 and 2, 1 by 4, 2 and 3, 0.75. Okay.
Correct. So, okay. So the CDF thing is clear, right? Can I ask one question?
Yes, ma'am.
Yes,
Sure.
ma'am.
Okay.
Yes, ma'am.
Now, if I have just given this thing only, I have just given the CDF part only. Okay, can you just tell me what is the probability that my x equals to 2? Can you tell me that? The figure is not given, only the CDF part is given.
1/2.
We'll find the difference.
How will you do that?
Ma'am, 0.75
Subtracting.
minus 1/4.
Yes.
0.75 minus
That is
0.25, which is 0.5,
1/5.
right?
0.5.
Similarly, probability that my x
Ma'am,
equals to
can you
3.
repeat
Huh?
Can you 1/8.
0.875 minus 0.75.
0.875, 0.75, which is actually
0.125.
0.1.
okay. So we can have a question in which the CDF is given, and from that you need to calculate the probabilities. So you can calculate it, you just have to subtract it. Fine.
What if, ma'am, x is 4?
Okay, so if x is 4, then you tell me.
It is 1.
Ma'am, 1.
1 minus 0.875.
That is 0.125.
Yes.
So greater than x is 5, then we can predict or not?
You can't predict because the values are till 4 only, no?
But here a is greater.
After that, it's constant, right?
At 4, it will be 1. For greater than n.
Let's take one more example from the activity. Let me see. Just a second.
Excuse me.
Okay. So
Hello.
okay. Have you guys opened the portal? So from that activity question, activity 9.6, question number 5 and 6. Have you guys opened it?
2 minutes.
Question number
Ma'am, which
5 and
question?
6.
5 and 6.
Ma'am, 9.6 or 9.5?
9.6.
Oh, okay, ma'am.
Yes, ma'am.
Okay. So we have the CDF here, which is actually 0 if my x is less than 0, 0.41 if my x is between 0 and 1, 0.78 if my x is between this, then 0.91 if my x is between 2 and 3, then 1 if my x is greater than equal to 3. Okay. Now the question 5th is actually asking, okay, so this cumulative distribution function of the number of defective items in the shipment of every 10 item is given. Find the probability that there are 3 defective items in the shipment of 10 items. So what do we need to find out?
P of x equal
Ma'am, we have to find 3, like
Probability
for
that
the
x
3
equals
defective
to
items.
3, right?
Yes, ma'am.
So this will be equal to
1 minus 0.91.
0.09. That will be.
So this will be 1 minus 0.91, which will be equal to
0.09.
correct. Okay. Now similarly, what is question 6 asking?
It is
At
asking
least
at least 2. So P of
At
x
least.
greater than equal to 2.
Okay. So now
X.
I can write this as. Okay. How do
Ma'am,
you
you
want to solve
can,
this thing?
ma'am, may I say, like,
Hmm.
we have to do like 1 minus 0.78 because we have to take at least 2. Means more than 2 also I can take 3, 4.
Yeah, ma'am. Yeah.
What?
Ma'am, 1 minus 0.78 because we can also take greater than 2. That's why.
So you was okay. Okay, I got this thing. Okay, you are doing it as 1 minus probability that x is less than 2 and x is less than 2 is basically what? 0.78. So this will be 0.22, correct?
Yes, ma'am. Yes, ma'am.
Okay. And if they don't know this, so what we have to do? We have to just calculate the probabilities x is greater than 2 in the sense probability x equals to 2 plus probability that x equals to 3, correct? You can solve it in this way as well.
Yes, ma'am.
Ma'am,
Is
like
this
adding
question?
all the two, 3,
Ah,
right?
yeah.
Okay, ma'am. Understood.
So you guys got to know what is CDF, what is PMF, what is a discrete and a continuous random variable and a random variable. So this was all in week 9. Is week 9 clear?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes,
Yes.
ma'am.
Okay. So if you got any one of like, nothing is remaining, right? Everything is done. Let's see. Random variable, done. Discrete random variable, done. PMF is done. Graph is done. CDF. Okay. That was all in week 9. So that is it. That's it. Any doubts?
No, ma'am.
No, ma'am.
Okay. That's it then. Shall we end the meet then? Yeah.
No, some examples from
You have
Ma'am,
doubts?
practices maybe.
ma'am, in this the same activity question number 3, can you just explain that?
Question number 3. Suppose it is known that X the number of cars that arrive at a specific lot during 1 hour. Okay. Find the probability that in specific 1 hour time period, more than 2 cars arrive at the car parking. That is probability of X is greater than 2. So it should be X is greater than 2, 1 minus. Okay. Okay. So basically what it is given. We have been given probability that x equals to x equals to e raised to the power minus 5, 5 raised to the power x upon factorial x. Okay. And they are saying that in specific 1 hour time, more than 2 cars arrive. That is probability that x is more than 2. Correct? We need to find out this. So I can write this as 1 minus probability that x is less than equal to 2. Correct?
Yes, ma'am.
And here my x is taking value 0, 1, 2. So this is a discrete thing. Okay. So if it's a discrete thing, probability of x less than equal to 2, I can write it as probability that x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Correct? Yes?
Yes.
Yes? Okay. Now this can be written as e raised to the power minus 5, x 5 raised to the power. In place of x, I will be putting 0 divided by factorial 0 plus e raised to the power minus 5, 5 raised to the power 1 upon factorial 1 plus e raised to the power minus 5, 5 raised to the power 2 upon factorial 2. This thing is clear till here? I've
Yes,
just put the
ma'am.
values of x. Okay. Now can I write this as 1 minus summation of x going from 0 to 2 e raised to the power minus 5, 5 raised to the power x upon factorial x?
Yes, ma'am.
Yeah, that's it. I think
Okay.
option number, yeah, there is an option. That's it. This
Okay.
is how you solve.
Okay, ma'am.
Okay.
Yes.
Ma'am, when we are given to draw the CDF, we don't have to show that vertical lines, or we only show the horizontal lines.
You don't have to draw a graph, like you won't be we won't be asking you to draw a CDF or something.
No, ma'am, because in question number 4 only that thing is given. That's why I was asking.
Oh, acha. Okay. So what
Yeah,
is the question?
that
Probability
thing
mass
they have
function is
given the
given, which of
values.
the following graph is the CDF of x?
Yeah, yes, ma'am.
So first thing is from 1 till 1. So first option is already out. So less than 1 should be 0, na? The second option is also not 0. So option C 0, then it 1. Mhm. Mhm. Yeah, you don't have to show that thing. If you see here, I've just drawn it with a dotted line, right?
Yes, ma'am, actually I chose option D and it showed wrong.
Yeah, it will be wrong. See, the CDF, the correct CDF is this thing. See, in here, have I drawn any line?
No, ma'am.
No, right? That's it. This is just for the your explanation. I've just drawn this dotted, and also for the explanation, I just like drawn a dotted line, not a single line, right? Fixed
Oh, okay,
line.
ma'am.
Yeah,
I get it. Okay.
yeah. So that was it. Okay, anything else?
Thank you, ma'am.
Okay then. So you guys go through once again. Those who have not gone through the lectures, just go it once again. I guess tomorrow is the deadline, right?
Yes.
Yes, ma'am,
Yes.
tomorrow.
Oh, yes. Okay then.
Ma'am,
So just
hello,
go through
ma'am.
it once. Yes.
Still I'm not able to
Hmm?
send my questions in discourse forum.
Sorry, once again. I'm not able to hear you.
Now it is audible, ma'am.
Yeah, you are audible, but you're too low. Yeah, you tell me.
Ma'am, till now I am not able to send my questions in discourse forum.
No, in the they replied. The support team has replied to you, na, to send you to send the recordings. Have you sent it to them?
Yes, yes, ma'am.
Have you? Sure.
Yes,
I'm not
ma'am.
seen. Where is it? It shows unable to. Okay. Where is the recording?
I have sent and one reply.
Yeah, it's not there. The support team has asked you to share a screen recording of the issue, but you are not. I'm not seeing any screen recording.
I got one reply from them as well.
You got reply?
Yes, ma'am.
To whom did you send?
To send my query to discourse forum supporting.
Yeah, so this support, you have shared it, right?
Yes, ma'am.
No, I'm asking where is the screen recording? I'm not able to see any. Like, whom did you mail?
Ma'am, supporting, not to you.
Yeah, to support them, right? So have they
Yes.
provided you any email for the discourse support team something?
Yes,
Have they?
ma'am. Yes, ma'am.
Yeah. So have you mailed
Yes.
to them?
Yes.
Have you put? You could have just put me in the CC. So that's why. So in that way, I could have also seen it, right?
Okay.
Can you just share me the? Just forward me the mail, okay?
Okay.
Yeah, I'll just look into it. Okay then. So that's it. So I was telling that go through the lectures once again and do the activity questions, the practice assignment, and the graded assignments. Okay. So tomorrow, I guess, tomorrow is your doubt session. So come with your doubts. Okay. Just do the activity questions and the practice assignment. Okay.
Okay, ma'am.
Yeah.
Bye bye, ma'am.
Okay. Bye,
Okay.
everyone. Okay. Bye, everyone. Have a great night.
Thank you, ma'am.
Thank you.